Hi, and welcome to question one of the Leaving Cert Ordinary Level Paper 2 in 2021. If you want to get access to more videos, please click the subscribe button. And if you want to copy the notes I'm working off, just email shanetroy@gmail.com. So question one here of paper 2 is probability question. So lots of words. Even just from the first look at it, you can see there's some scenario here involving hands and feet, and then another scenario here involving colors. So if you've practiced probability, a classic spinner question. So what does the question specifically talk about? Apologies for all the words. The game Twister is played using two spinners and a mat with colored spots. The two spinners needed for the game are shown below. Both consist of four equal sections. A player spins both spinners and must then place their selected hand or foot on the selected color spot of the game. So classic Twister. The spinners below show the outcome of right hand on a yellow spot. So currently those arrows, whatever, pointing to right hand and then the other one to the yellow color on the other spinner. So it says, first part A, how many different possible outcomes are there in the game? So I suppose it's a question of it's spinner 1 and spinner 2, okay? Because it says the game, I suppose, consists of two spinners. Now, the and scenario, you multiply the outcomes. So there's four outcomes here on the left, four on the right. 4 times 4 is the 16. Now, there's, I suppose, in a sense, other ways to do that particular question. That's, I suppose, the more mathematical way. Just seeing the answer, okay, I've kind of tried to detail that, but you could have written out literally every single option that come up, okay? And you see there, if you just kind of read through it, RH stands for right hand, Y is for yellow. So right hand with yellow, left hand with yellow, right foot with yellow, left foot with yellow. And then do the same thing for the red, green, and blue. And you count it up, you have 16 different possible outcomes. No right or wrong. Okay. Doing it up here with the different outcomes listed out would be easy to make a mistake, whereas the calculation is cleaner, if that's something that's important. Okay, so in part B, part one, we have a kid spins each spinner once. What is the probability that she must, in different scenarios here, she must use her left foot? Now, if you remember from before, we had 16 possible things could happen. So I suppose, in a sense, probability is equal to the number of actual things that will happen, okay, over the number of possible. Now, excuse the bad writing. Now, on the bottom there, the number of possible outcomes is 16. On top, how many would involve the left foot? So you think about the right hand with all the colors, right foot with all the colors, left hand with all the colors, and left foot with all the colors. So there's four colors, so there's four outcomes. Now 4 over 16 is the same thing as 1 over 4. Okay, so there's 1 in 4 chance. Now in the notes here, I suppose I've just kind of taken the same idea from part A, where I've listed out all the different outcomes. I'm just looking at it going, well, 16, okay, and then I have 4 of the 16. So you could do it again. There's multiple ways to do these questions. Now, the next one then is, what's the probability of using a red or yellow color spot? Now, there'd be 4 reds, okay, and there'd be 4 yellows out of the 16, okay, and out of the 16. So the red or yellow in probability speak, or means add. The and rule means multiply. So if your question is obviously saying or, you just add the probabilities. Okay. So 4 out of 16 plus 4 out of 16 is the same thing as 8 out of 16. That's the same thing as a half. Now in the answer here in the notes, I've kind of tried to do that same thing in math speak, but also again taking the sample space and identifying how many of them are red colored and yellow colored. And then that's all of them. So if you see, it makes up half of the sample space. That's another maybe more intuitive way of getting the answer. Now the next part then says So in part C, Jack spins each spinner once. What is the probability that the outcome is? In part one, they're saying his right hand and a blue spot. Now, the second I see and in a probability question, I go, I'm going to have to multiply the options here. If it was or, it would mean add. Okay, so in his right hand, okay, there's 16 options in total, and I get four of them, right? It's four of them. Multiply by the blue spots, there should be four blues out of the 16. So 4 times 6, what's this, multiplication? 4 over 16 times 4 over 16 is 16 on top. 4 is 16 on the bottom. 16 by 16 is 256. I can simplify that down to 1 in 16. I probably could have just done that easier back there, but anyway. And that's the answer. Okay, now if I went to the sample space we had before, if you see it written out, how many of them are right hand and blue? Now, or would mean there's more options than that. But which one is right-handed and blue? It's that one. That's one of the 16 options. Okay. Now, going back here, so then the next one, part two, and there's no harm pointing out now that sometimes probability is kind of counterintuitive. This question here is one that would wreck my head trying to think it through. But um, spinner, spun, whatever, probability outcome is the right hand or blue spot. Now, when I see or, I think immediately, I'm going to have to add. Okay. Now, the probability of right hand, well, that's we said before, that's 4 of the 16 options. Now, or, again, the blue spot, just like we had at the top, is 4 of 16 options. Now, that creates the calculation 4 of the 16 plus 4 of the 16. Add that, same denominator, so just add the tops, 4 and 4 is 8, 8 of 16. And you would think that's the answer. Maybe you might go, oh, I'll simplify this to give a half. Whatever. Now, the trick here is this is a case where they're not mutually exclusive. I hope I'm getting that right. And I'll flick on to the sample space to show this again and try to get rid of some of this writing here. If you think what's happening here, okay, we're counting up all the right hands and all the blues. Now, if you see that, there's actually 8 outcomes there. Okay, so think that's cool. But this outcome is counted twice. It's counted in the right hands and it's counted in the blues. So you've counted it twice. You need to control for that. Okay, now go back. Sorry. So we said there was 8 out of 16, but one of them's counted twice. So we take that one away. And that calculation then becomes 7 over 16. Now, I may have said it wrong before. It was right. Not mutually exclusive event. Okay, where there is overlap between the two things. Other situations in probability can be mutually exclusive, where there is no overlap between the two things. And it's important to recognize where, each situation is in order to be able to fully answer the more complicated questions. Now, if you come out of probability with a good score, like 20 out of 25 marks, whatever, you're doing pretty good. So don't beat yourself over the head if the harder probability things are beyond you. They're often beyond me. So it's counterintuitive. So it's almost the opposite of what we would just naturally think something would be. So you have to fight against that, and half of that fight is practice. So I think that's the end of question one. Okay, so see you on question two.